I've already tweeted a link to a blog post that I put out because I changed the title of the talk, as I just told, as I say. Because after chatting to some people earlier this week, I think it's much more useful for me to focus on one of the pieces of the personal cloud stack that we're working on. So I'll be talking about Unikernels. And the slides are already up at that link, and something I'll be asking you to do is to send me feedback about this talk at the end, and I'll share with you a link then so you can go to a web page and just essentially rate the talk and tell me what you thought about it. So just overview. This is roughly the size of this is roughly where I expect to spend most of the time, is talking about Unikernels, a little bit about at the end about why I care about this and some other deployments. And a little bit about me. I am a program manager, project manager. I think about product stuff in a group called the Camel Labs in the University of Cambridge in the computer science department. I do a lot of community stuff for Mirage OS, which is the project I'm going to talk about. Mostly I heard cats. I like systemsy stuff. My background covers physics. I used to be a neuroscientist. I'm now kind of pretending to be a computer scientist. And I've worked in startups and big companies. So if you think about software today, essentially it's very simply, it's an application and it sits on top of an operating system. But it's not just that. We build this stuff locally on machines that you have with you. But these days you deploy it remotely. So the environments that you're pushing these things into is quite different, and there's lots of complexity in between. And so that means you end up needing far more tools to make this work properly and consistently and reliably. So software is complex. But the funny thing is, most of those applications that we're shipping are single purpose. When we push things out to the cloud, they essentially just do one thing. And complexity here is the enemy. So when things are more complex, you have more layers. That makes the configuration tricky. All that duplication of that same essential stack everywhere is inefficient. The huge sizes of the things we're pushing around means that it takes a while for those to boot. And just generally, the more stuff you have, the more stuff can go wrong, and the more places, the larger your attack surface is going to be. And there's just another question underneath all this, is why are we building software for the cloud the same way that we did it for desktops? It actually doesn't make sense if you dig down and think about it. So can we do better than this? And of course the answer is yes, we can. So here are the things we essentially need to try and do, is disentangle the applications from the operating systems themselves. You can think of these things separately. Break up all that operating system functionality into small modular libraries so that you can compose them. Only pull in the bits of that system functionality that your application actually needs. Ignore the stuff that it doesn't need. And also make it really easy to target multiple platforms using the same code base. And so this is where Unikernels come in. And quick definition of Unikernels is essentially they are specialized virtual machine images. They're built using a modular stack where you pull in all the system libraries and the configuration along with your application code, and you produce this single-purpose virtual machine with a single address space. Another way of thinking of it is every application is compiled into its own specialized OS that runs on the cloud or on embedded devices. And I'm specifically going to be talking about Mirage OS. So Mirage is written in a camel. So that's a strongly statically typed language. Essentially, one of the good things about a camel is it has a very, very good module system and a very good type inference engine. And what we've had to do here is essentially rewrite a lot of the protocols, like TCP and a whole bunch of other things, in pure camel. That's taken many years of work, but it's been worth it, and that essentially is what makes producing a unikernel using a camel code possible. This is essentially how it works. So you take this giant stack of stuff, you run it through the compiler, and you produce that small unikernel, small pile of stuff at the end, which is the unikernel. And you can target this to essentially different backends. The important thing is the development cycle is familiar to you, but the deployment scenarios are still quite broad. What that means is you don't have to use the entirety of the tool stack. You can develop your logic using the native stuff that's available to you on your Unix-based machines. So all the networking stuff that's available just that comes with your OS, just with your extra application code on top. Then you can swap out the native Unix stuff and use the Mirage OS system libraries, the ones that we've rewritten, and that allows you to test your code. And then you can think about deployment. And this is just a command line flag, essentially saying, I'm not deploying on Unix now I'm deploying on Xen. And same code runs, and it targets the Xen hypervisor, which can be running on either x86, so this is the public cloud that we have today, or Xen on ARM, which is embedded devices for the future. So the same code base. So what? This all kind of sounds cool. A lot of this work has been done in academia for a while. And one of the things I want to get across is this method of creating and deploying software is very good because the binaries that you produce, the virtual machines, they're really, really small. And that lends it's a lot of benefits. And they're also, because they're small, the attack surface is smaller. And so a lot of things become possible with this approach that are not possible using the traditional stacks. And the example I'm going to use to try and lead you through this is that of static websites. Does everyone know what a static website is? Cool. The reason for this is because it's easy to understand. I use Jekyll for my website, so I'm going to talk. So we can think about how we take Jekyll and turn that in Jekyll website and turn that into a unikernel. But the process is the same for any application that you write. It's important to bear that in mind. So these are a bunch of static websites. That's my blog post, which is live on the left. On the top right, you have the Mirage website, and this is another one of the contributor websites, and that's something we call a Bitcoin Pinata, which is another, essentially a static website using the new TLS stack. So let's focus on this one first. So I've said that they're small. How small? Anyone want to take a guess? So this is a unikernel, which is only using the bits of the networking stack that are required to essentially serve some traffic over the internet, and it holds a bunch of bitcoins. How big do you think the equivalent is in the traditional stack? Anybody want to guess? How much of the other side of the screen am I going to take up? Close. It's 200 megs. So that is about 25 times bigger than this, but they're both doing the same thing. The really important thing is this one on the left doesn't have any extra stuff. There's no shell here. There's nothing to log into. There's nothing to break into and to manipulate or to pivot around. That on the other side could have all kinds of stuff that's there in the stack. You can't hold all that information in your head. So you don't actually know what's running in there. So if you're trying to run something secure, which this Bitcoin Pinata is, that attack surface is huge. And just for fun, if that was planet Earth, what would this other one be? Louder? It's Pluto. And I'm kind of cheating a bit because I'm just considering the area of the circle there. But that's an example of how much smaller these things are than the traditional stacks that we're using today, but with the same functionality. That's important. And these are also really easy to deploy. Because they're so small, you can check the entire thing into Git. And who uses Git? Show of hands. OK, so the workflow that you're familiar with Git in terms of Git push, Git checkout, all of that stuff, all becomes available to you. With the thing you're checking in is the virtual machine. It is the application. And that means you can get to Heroku for Unikernels in about 100 lines of code. It's actually a bit more now because the rest of the development team added a bunch of extra stuff. So I'm going to walk you through an example of what this looks like using a unikernel. So now I'm going to switch. And if any of you read my blog post already, you realize I have not prepared this. I was writing this talk yesterday. So this part is live. We'll see how this goes. So going to here first. So this is the post. So just to let you know that you don't actually need to go. All the links are here if you want to follow them. Essentially, we're going to build a static website. We're going to take a Jekyll website and turn it into a unikernel. And helpfully, we've got Mirage Skeleton. So Mirage Skeleton has a whole bunch of examples. So there's a DNS server, there's a bunch of stuff. Here's static website. We also have a secure static website, but I'm just going to look at static website. So we have two files that we need to use here, config and dispatch. I'm not going to dive into the code. I'll just show you what it looks like. So you get an idea of how it works. So you can configure this, but it pulls in things from the environment to figure out what instructions you're giving it. For example, direct and sockets for what networking stack you're going to use. So I won't dwell on that too much. It's sent now for my website, which is a Jekyll website. I'm using GitHub Pages. I just added an extra directory, _Mirage. I've just dumped those two files in here. And I'm glad to see that screen. And very minor change in here. And has anyone used Travis before? So Travis is a CI system, so we've hooked this up to Travis as well. So this is what the build script looks like. This is fairly straightforward. So we're getting in a camel environment, a bunch of extra stuff, and then here are the commands that we actually use to build. Oops, make Very simple. And then the rest just happens. And there's also a deployment step we'll talk about. And so Travis has built. This is the post I pushed earlier. So it built, it went live. This has also now been checked into Git. My site is actually still running on GitHub Pages for the moment because I haven't finished the tool chain. So what we're going to look at now is the Mirage website. No, yes, the Mirage website, which is here. So the first thing I'm going to do is talk you through the whole tool chain using the Unix and then moving on to how we deploy to Zen. So there's nothing worth showing locally at the moment. So now I'm going to switch to here. Can you see that? Okay. So we are here, and we're in the source directory of the Mirage website. Looks like this. There's a lot more stuff going on here. I can show you what the config file looks like. Quite a bit more complicated. This is one of the first sites that we built to essentially dog food our stuff. And so we're going to first build locally, configure Unix. That's all it takes. I have the entire camel toolchain, the appropriate toolchain already installed, but I actually want to run this using the Unix stack. So I'm going to do this. That should do some stuff. That worked. That also generated a file. We can see what that file looks like. Bunch of stuff in here. I'm not going to dwell on this either. So this essentially is more information about the configuration for that Unikernel. All this will get compiled into the Unikernel. Now we just make. And we sit and wait and twiddle our thumbs. And that's it. That's now built a Unikernel. It's here. And we can see and we can run that now, and it will run locally and do some stuff. And now we should be able to see this here. Yay. So this is a site now running locally. So you can see the model is fairly straightforward. Write your application. You can test things locally. You can, it will all work. And now I want to deploy that out to somewhere else. So what I could do is, if I wanted to take the same code base and now compile it for the cloud, I would do this. But I don't want to do that on my machine here. I actually want to do that through a whole tool chain. So this is where we hook into Travis. So this is the actual website for the Mirage. Whoops, that's not supposed to happen. So when we push here, what we want is Travis to pick this up and do all of that build for us. So build the Zen Unikernel at the end. So this is the last push that happened. Ignore the little red thing there. This was the last successful build. And if we follow all this all the way to the end, you'll notice that we've also got a part where it finds a deployment repo and pushes the built Unikernel into that repo. This is that repo. And so we can look at the size of this Unikernel now. If I have it here. So those are the two images. So it's pushed the zipped image, which is, as you can see, I've already been trying this out. So the compressed image is 4.6 megabytes. That's what's checked into Git. And the uncompressed image that we're going to run is about 15 megabytes. And that's the entirety of the site. That includes all the stuff that's needed to serve all the traffic, the web server, the networking stack, everything. That's the entirety of the Unikernel. And that gets deployed onto a machine. And so we have a whole bunch of scripts that essentially live in the deployment repo. We have another machine that we host on Bytemark that essentially pulls from this repo, looks at what's changed, and then turns off the old virtual machine and turns on the new one. And then you end up with a deployment that goes from what's happened on your machine to all the way up on the live site. And that's an end-to-end tool chain. And we've only had to add about 100 to 150 extra lines of code, which is basically a bunch of scripts to glue the things together, because we have a very simple, it's a very small, simple thing that we need to push around. Does that all make sense? Some nodding. Okay. So that's essentially what the procedure is for building a unikernel and pushing it out live. And that workflow is general. You can apply that to any kind of application that you're building. It doesn't have to be for a static website. This is just a simple example to get your head around. So there are other ones that have been deployed. So the Bitcoin Pinata is a really interesting one, because we built, members of the team built a complete implementation of TLS in PureCaml. And what that means is we can now build secure unikernels, and that's essentially what they did. So they took a bunch of Bitcoins, put them into a unikernel, put it on the internet, and said, break our stuff. That's been up since about February, and the Bitcoin is still there, so we assume that's a good thing. We can't prove security by the absence of anyone hacking into it, but it does provide some faith in the rest of the stack, because that pinata has been bombarded, and it has stayed up. Other clever things you can do are this slightly crazy stuff, like a unikernel of a virtual machine for every URL. So every URL on your website, you can write by writing a short script. So Magnus did this with about 80 lines of Python. Spin up a unikernel with a full stack for every single URL, right down to the small PNG file for the RSS feed was being served from its own virtual machine. I don't know why you want to do that, but it was cool. And just try imagining trying to do that using the traditional tool stacks. So this kind of experimentation is only possible when you take this kind of approach. And other people have built other simple HTTP REST services, and we also have a bunch of other tools as well related to data storage. Of course, there's a trade-off. Everything here is written in a camel. So if you want to use this stuff, for now, you have to write all your things using a camel. But that's only for the time being. So in the long term, we know that we need to think about how legacy applications will work with this as well. And so now I can get on to why I actually care about this. And this is what the talk was originally going to be about. But I want to give you more of an overview of unikernels first. So essentially, I want to help empower individuals to own their own piece of the internet. And in order for that to work, we need to have distributed personal clouds. You can't really, no one wants to be a sysadmin for just running their own infrastructure. And so to achieve this, we need resilient, scalable systems. And that's essentially why I care about this. So I use a whole bunch of different services. And this is great as a developer and also as an end user. But this is much more like feudal computing, because when these things change, when the services change their rules, when essentially after a while you start to feel like your cattle being grazed for the data that you're producing, because there's always something new coming up. There's always someone else who wants to access your contacts or your something else. And what value am I really getting from that anymore? So there's a slight sense of malaise. And it's sad. So the only way that I see out of this is to make it possible for every individual to start owning their own piece of that internet, but without having to become a sysadmin. So we need the reliable, secure, scalable infrastructure to make that possible. And so that's what this stack is about. So Mirage is one piece of it, which is how to build the application, how to deploy it, the entire lifecycle management of the software. Ermin is another piece, which has a whole talk all of its own on data storage. So it speaks fluent Git. And Signpost is a new project, which is about how you form connections between all your devices. So I can talk from my phone to my laptop over the local network without having to route through the cloud. And essentially, the first few applications to target will be mail, contacts, and calendars, because they are the core of everybody's infrastructure. If I don't trust this stuff to run my email, I'm probably not going to trust it full stop. So we do have an IMAP implementation and SMTP. I'm not using it yet. It's still in alpha, but it kind of works. So there's a pathway for us to get from the tools that we're using now to tools like this, which you can run for yourself. And another reason this matters is because there are way more devices like this coming that are going to be arriving in the next few years. This is the whole wave of Internet of Things. And a lot of these things don't need a cloud backend. They just need something quick to help form a connection between two endpoints on the network and then do some stuff. And that stuff can actually happen locally. Has anyone heard of the Goodnight lamp? A few hands. So just to describe it quickly, you buy that big box, you give your friends and family the little box. When you turn the light off and on the big box, it turns off and on the little boxes. That's it. So that's quite neat if you have family all around the world, because they know when you're home. And it's just fun. But that needs a back-end service to perform the identity, perform the connectivity, and pushing little bits of information around. And that doesn't have to be a cloud service. If they end up going out of business, all those little light boxes in people's houses, they don't work anymore. And Nest, for example, is an interesting one, because you have a thermostat, and think about what the life cycle is of a thermostat in your house. How long will that actually be there? But then people are faced with issues like this. And this was a tweet a couple of days ago. So what's my option if I don't like the new license agreement? Change my thermostat? Do I really want to do that? And so that's why I think we need to move more towards a world where essentially people are able to take control of their own infrastructure without having to give up everything to a third party. So you can contribute to this stuff. Everything I've talked about is all fully open source. Mirage.io is the core of the infrastructure that helps us build the unikernels. There are also other unikernel implementations out there in other languages. So just off the top of my head, HalVM is using Haskell, Ling is Erlang, and there's a bunch of others as well. Nymut is the website where we're aiming to take the unikernel approach and apply it to personal clouds, and a camel is the language that we're building all of this stuff in. And I would really like your feedback. So I've put up a page, amirchaudhry.com/feedback. If you go there, you'll see just 2 simple questions. Rate the talk, and would you recommend it to a friend? And a little box if you want to tell me anything else. I would really, really like to know what you thought, both about what I talked about and just anything else you want to say. Oops. And I finished earlier than I thought. I was worried about overrunning. So we have time for questions. So you have a choice of whether you want to use the networking stack that is part of your operating system underneath, the Unix networking stack, or whether you want to start using the libraries that we've built. So for example, if I want to use the networking that's there on my Mac, I can target Unix but use the Unix networking infrastructure. But if I want to use the libraries that we've built, the TCP stack and the other parts of the tool chain, then you can use I'm waffling now. Yeah, you can either use the libraries we've built or use the libraries that are available on Unix. You get to choose. So the reason for doing that is you develop your application logic using the stuff that you know already works, and then compile it again using the system libraries that we've written just to check that everything's still working. Did that answer your question?
So I totally agree that the cloud should be given back to the users, but can you explain again how unikernels do that better than traditional operating systems?
Because they're so small and easy to manage, it makes it firstly there's security benefits. So unikernels are inherently more secure because the attack surface is much, much smaller. And there's a whole class of bugs that won't be part of them because of the way they're developed. And if you can make things much, much smaller, you can deploy them to more devices. So imagine taking the unikernels and employing them to embedded devices so you can run such services in your home. And if they're just as performant, they do the same job as something else, then it's a lot easier to keep them up to date because you simply start a new virtual machine if there's an update, rather than have to worry about patches and update and essentially becoming a sysadmin. So the idea is to avoid becoming a sysadmin. So you can either run this yourself, or I can trust someone else to run it for me. But in either way, because I'm using fewer resources, the attack surface is smaller, there are benefits in terms of cost and security.
Yes, so I didn't understand exactly. The principle is to run on the bare machine, right? You run the unikernel on basically a bare processor, right?
We run it on Zen.
Yeah.
So perhaps I wasn't clear. So Zen is a hypervisor. So it provides a virtualized interface. So we target Zen, and Zen.
So it couldn't run on QEMU or something.
Pardon?
You couldn't plug that into a QEMU or a really.
I think we've done some work in that area, but for the moment we're just focusing on Mirage. Okay. Sorry, on Zen.
Yeah. Would you like the technical question or the political question?
I'll try the technical one first.
You talked about checking in the built blobs into Git. I wouldn't want to clone that repo.
That's a good question, and I literally did do that to see the sizes of the Unikernel for Mirage. You can do shallow clones, so you don't have to clone the entire thing. So I just cloned literally the last commit.
Cool. And the political question, there's this dynamic where all of the cloud services host all of my data. So Google owns my email. I have a slight hedge against that, but it's in Google's interest to keep owning all of my stuff. It's not in Nest's interest to make a thermostat that makes it easy for you to swap other software in. Do you foresee a world where people make lots of things that put people's own control of their data as a priority?
There's an interesting question there. Hey, can I?
Yep.
The interesting question there is about business models, because that's another thing that I didn't talk about now that also has to happen, is we need new business models for essentially ways of making money on the internet that don't involve harvesting loads of data. That will essentially solve that part of the problem, because you can't ignore people who other businesses who want to make money. So the idea is, if you can build services like this that are small, if you can charge for something else, perhaps charge for the service and it's metered much, much lower and just have more people using it, there may be another business model in there. And that's where the challenge is from the other side, is that there has to be a way of making money. Because if there isn't a way of making money, it won't get adopted.
How does the performance of your system libraries compare to more mature operating systems?
As good. So we've done, there are papers that if you look at the Mirage website, they will be linked to. So for example, we did a DNS server. We got that down to a few hundred megabytes, and we compared the performance of that with, I think, Bind and another one. And the performance is, the throughput is just as good. So you're not taking a hit in terms of how useful these tools are, but you're getting all the benefits of having something way, way smaller and way more resilient.
So, how are you doing persistent storage? Since right now you're having static images.
So the persistent storage is part of the story I didn't talk about, and that's Ermin, which is a Git-like data store. So it speaks fluent Git, and you can treat it as an append-only store. So you can push data into that and use that to persist data. I didn't really talk about that too much because that's quite involved. But that will be that's the story for how we do data persistence.
What's the query language for that?
I'll have to talk to you afterwards. But yeah, it speaks fluent Git, so you can.
Not the answer I was expecting.
I don't necessarily know all the details. So it's not a database. So so you can interact with using all the Git tools that you already have. So it will. Does that make sense?
How do you
Or no?
fetch something out of it?
It might be easier if I show you a quick demo. So there's a video I can show you.
How do you spell it?
IRMIN. So if you search for Mirage Ermin, you'll probably go to the blog post where we describe all of it. Also, I don't know that much about it yet. It's still very new.
So it's kind of an extension of that question about the new business models, because we need to run it somewhere, right? So we can build our own kind of secure thing for ourselves, but we would need to run it somewhere. So we would need to buy a service from somebody. We would need to trust them, and they would need to have some kind of good business model because the images are small. So I don't know how they will make money. In terms of, there are already ridiculously cheap cloud storages, like this $5 clouds. So do you have any ideas on your blog, or can you direct somewhere where you can read about it? Like the new business models and the ideas of how to deploy all that in a secure, trustable way somewhere, so I need to run my own hardware service?
There are ideas. So there's another project we're working on with a collection of other universities in terms of looking at business models for example, personal data. So if you make it easy for loads of people to capture information about themselves, can they monetize that data somehow? In that scenario, all the stuff is staying within the home, because technically that's easier for them to build. But in the long term, they're also thinking about how you'd build such a system in a distributed way. So if you want to search for that, you can search for hat project. I should add that link to the blog post as well. But there are people considering business models too.
Any more questions? The last one? No? Okay, thanks for the
Thanks.
discussion. We're gonna make a 10 minutes break, and after that we got Nikita with talk programming web UI with database in the browser.